Rafi, thank you for that introduction, and I'm really delighted to be here. It's such a distinguished audience, and John gave a lot of good tips. I think one in particular stands out. If you are an innovator, and I give this advice to all innovators, it's free advice. File a provisional application. If you don't have the money, go and explore the business options. You know, you have a year to develop your business. So it's always a good idea to go down that path. I'm going to talk about innovation, the importance of protecting your innovation, and some pitfalls that you run into in protecting your innovation. And I'm going to do this using some real-life examples, some stories from my own practice over the years. So I'll start with my first story, and then just figure out how to make this work. Oh, shoot. Okay. I'm going to skip my sports story. I went too fast. Oh, shoot. Whenever there's an image, it takes a long time to come back on. Well, you guys have a great hospital, but not so good IT. Oh, okay, there we go. Okay, so my first story is about decorating cakes. And you know, it's hardly a sexy area for innovation. And when I think about decorating cakes, I usually think about squeezing some frosting onto a cake. And the great innovation I always thought was taking a Ziploc bag, filling it with frosting, and then cutting, you know, one of the corners and using it as a squeezy. I always thought that was a great innovation. But when I was in private practice, I litigated 3 separate lawsuits relating to decorating cakes, and 2 of them all the way to the Court of Appeals for the Federal Circuit, which is the, you know, ultimate appellate court for patent law. So it is a hotbed of innovation. And when you think about it, it's easy to see why. There are 300 million of us in the US. Everybody has a birthday cake. So it's a huge market. And it's global. Even back home in India, now most middle-class families will have birthday cakes for their kids. So it's really a giant market. So here's my scenario. You own a food company. Let's say it's called Acme Foods. And you're in the business of food products, decorating equipment, what have you. And you license characters from Disney. So characters like Winnie the Pooh, etc., to use for food products. So what you do is you make cookies shaped like Winnie, or you have chocolate molds shaped like Cinderella, etc., etc. But you think that if you can find a way of putting these characters on a birthday cake, you will hit pay dirt, because you know the market is huge. And so you get your R&D folks, and they start working, and they come up with a method of putting these characters on a cake. What they discover is if you make an edible sheet which is soluble in fat, and if you take that edible sheet and then you print a character on it, screen print a character on it, and then put it on the frosting of the cake, it'll dissolve and leave the image. So you figure out how to make this edible sheet. You use a process called screen casting. It's a special process. You can make very thin substrates with it. So you use screen casting to make this very thin edible sheet that is soluble in fat, you screencast it onto a waxed sheet. You let it dry, screen print Winnie, whoever, and then peel off the sheet, put it on frosting, and you have a cake with Winnie the Pooh. Now this is a true story, except for the name. So this is a large food company. They had this great innovation, and it's about 2 decades ago, and they got a patent on it. So they did the right thing. And this is the claim. John talked about the claim, how the claim is a single sentence which kind of defines what the scope of your monopoly is. So this is the claim that they got on it. It's a 4-step claim. You select an edible fluid material. The step B is where you do the screencasting. Then you dry it, and then you screen print the image on it. So I want you to think about it, and I'll come back, like Paul Harvey, we'll do the rest of the story. My second story is not about jazz. It's about medical innovation. You all know more about abdominal aortic aneurysm than I'll ever hope to know. So you guys are all experts. And you know that at one time, the way to treat AAA was, the only way to treat it was surgically. So you cut open the abdomen, you expose the aorta, you divert the blood flow, cut off the aneurysm, put in a graft, sew up your patient, and that's how you did it. But it was extremely invasive, required lengthy hospitalization, lengthy recuperation. So people all over the world were working on a less invasive method of treating AAA. There were groups all over the world. I think there was a very big group at UCLA. There was Dr. Juan Parodi in Argentina. There was a group in Australia. And this kind of coincided with the development of coronary stent technology, because that was all endovascular. So, you could use a lot of that technology. So these people worked on it for a long time, and they really couldn't figure out how to come up with the right product. The problem was the disease itself. As you know, the aorta varies from patient to patient in its size, length. It's very tortuous. The 2 iliacs that go into the aorta, both of them can have aneurysms, and they're also very tortuous. It's very hard to figure out how long the aneurysm is. So when they would go in and put in the graft, because they couldn't figure out how long the aneurysm was, a lot of times they would end up with a graft that leaked. So they had these things called endoleaks. You could not get a leak-free graft. Until these 2 guys in Australia, a physician, Dr. White, and a Ph.D. scientist, Dr. Yu, they figured out what to do. They realized that what you need to do is, instead of using a single graft for the aneurysm, you need to use modular overlapping grafts. So you put in one graft, and then you put in a second graft that overlaps with the first one, and then just like a trombone, you move the